Hello everyone, I hope all of you are doing well. Here I am back with another type of question which is also related to Thevenin equivalent. In this problem there is a transformer. Now here you have to find the VTH and RTH across the load side. So what we have to do that we have to transfer all the source side components to the load side. Then it will look like a similar diagram that we have already solved. Now, how to transfer the components from the primary side to the secondary side, that I will explain in some other video. As of now, I am just going to tell you the formulas and I'll explain this problem. Okay. So, in this transformer, you can see the turns ratio is 1:2. So obviously V1 or V, let's write VP, P for primary and S for secondary. So VP upon Vs, that will be 1/2. Alright. So in this case, or you can also write this is also equal to N1 by N2. This N1 is the turns, number of turns in the primary side, and N2 in the secondary side. Okay, so now to transfer any voltage source, you have to use this formula, which is let's say V primary when transferred to the secondary. Let's put a dash over there. So Vp dash will be Vp into N2 upon N1. Okay, basically, so voltage is basically proportional to the number of turns. Remember that. Alright, and current is just opposite to this, because voltage and current, the power will be always constant. We cannot change the amount of power that is coming from one side. Okay, so Vi will be constant. So if Vp dash is equal to Vp times N2 upon N1, then Ip dash will become Ip into N1 upon N2. Alright, and to transfer any resistance, in that case the resistance Rp dash will become Rp times but N2 upon N1 square. You can also get this from V upon I. So basically R is equal to V upon I, right? So Rp dash is equal to Vp dash by Ip dash. So that will be Vp into N2 by N1 and Ip into N1 by N2. That will give us Vp upon Ip into N2 by N1 whole square, and Vp upon Ip we can write as Rp N2 upon N1 whole square. So this is how you can get the formula for resistance. So basically you have to remember these three things. Alright, so resistance is also proportional to the number of turns. Actually, like if the number of turns increases, the resistance will increase and the voltage also will increase and the current will decrease. Alright, so now you can easily convert this diagram to a simpler format. So how? So there is two voltage source and like two resistance and two voltage that is given on the primary side, right? And N1 upon N2 is 1 upon 2 in this problem. Okay, so if I convert this 1.5 ohm to the secondary side, it will become 1.5 into N2 upon N1 whole square. That will be, here I can do N2 upon N1 is equal to 2. So it will be 1.5 into 4, that is 6 ohm, Then similarly 3 ohm will transfer to the 3 into 4 again, so it will become 12 ohm. 2Vx, that will become 2Vx into N2 upon N1, right? So that will become 4Vx, and we have another Vx that will become 2Vx. Now let's redraw the question. So we have a voltage source at the left hand side, which is 4Vx now, plus minus. Then we have 1.5 ohm resistance, which is now 6 ohm, and then we have another 3 ohm here, and that has become 12 ohm, and the voltage also 2Vx. And the right hand side we have 3 ohm and 1 ampere current. So here it is 3 ohm, and we have a current source of 1 amp. So this is the problem now. Now we have already solved this type of problem. So how to do this? If you are still getting confused regarding how to solve this, I recommend you to see the video that will be coming here, the link on the screen. You can see the link now. So how to find RTH? To find RTH, we have to delete all the voltage and current source. So voltage source will become short circuit, and I'll write it again. Voltage source becomes short circuit and current source becomes open circuit. But don't forget that this is for the independent source. Independent source. If there is an independent source, you have to solve that, keeping that in the circuit. So we have one dependent source, that is 4Vx, right? Okay, so now just remove this 1 ampere from here, and you have to connect a current here that is of 1 ampere, or you can connect a voltage source also of 1 volt. Now you have to find the voltage across this current source. How to find this? So let's try this nodal equation. Now let's take the nodal equation at this point here. Okay, and as you can see, the voltage, if we consider this part is ground, this side is ground, so then this point will have a voltage of 2Vx. As you can see from here, if we go like this, there is a voltage source of 2Vx. So here we can assume the voltage is 2Vx. Okay, now the current in this direction and in this direction will be equal to the current incoming from this side. Yes, it's like KCL equation. The KCL equation says that the incoming current and the outgoing current, the sum of those current will be 0, right? So if this current is coming, and this two has to be equal to the incoming current. So the incoming current is 1 ampere. In this side 1 ampere is only coming, so 1 ampere, right, 1 is equal to the current in this side, in this path, will be 2Vx, voltage by resistance is 12, fine. And in the other side, like this path, the current will be there is a 4Vx voltage source another, so the voltage difference is 2Vx minus 4Vx, yes, and by 6. Now if we change the current direction, then we have to take the 4Vx minus 2Vx. Alright, now if we solve this, we'll get 12 in this side, 2Vx plus 4Vx minus 8Vx. So that is 12 is equal to minus 2Vx. So Vx is equal to minus 6. Now Vx is equal to minus 6. We have to find Vth, which we can get from the current source, the voltage across the current source. So the voltage across the current source will be, see this point, the point we took, that is 2Vx. So at that point the voltage is minus 12 volt. Okay, and the current is flowing through the 3 ohm resistor, so there will be voltage drop of 3 volt. See here in this part, so since the current is flowing like this, so there will be voltage drop. In this side will be plus and this side will be minus, and there will be voltage drop 3 volt. Okay, so the voltage across the AB terminal will be plus 3, then minus 12. So basically we are taking this path. So as you can see here, we have one voltage, and when you're going through this, we are getting another voltage. Alright, so minus 3 plus 12, that will be minus 9 volt. Okay, so this is the voltage across the current source. So the RTH will be V upon I. Here we will not take the negative value because resistance cannot be negative, right? So the voltage is 9 and current is 1, that is 9 ohm. Now we have to find the VTH. Now again we are going to use the nodal equation in that node only. So we can also say that the sum of all the outgoing current is 0, or sum of all the incoming current is 0. You can take any you want. Okay, let's take all the outgoing current. So on the left hand side there will be 2Vx minus 4Vx by 6. In this path there will be 2Vx by 12, and there is another plus 1 ampere. So sum will be 0. If you solve this, you will get minus 4Vx and plus 2Vx plus 12 is equal to 0. So Vx is equal to 6. So 2Vx will be 12 volt. Now this is only the voltage across this part, across the 1 ampere current source, and that only will come to the AB terminal because there is no current flow in this 3 ohm resistor, so there will be no voltage drop for now. So the voltage whatever you are getting here, that same voltage you will get over here. So that's how you will get the VTH. I hope you don't have any doubts after this, and still if you have, and if you have any suggestion for me and about my explanation, please write down in the comments. That will obviously help me to improve the quality of the explanation. Okay, thank you.